Okay, this video here is to hopefully refresh your memory for box and whisker graphs in the 5-number summary, and also outliers using the 1.5 rule. So box and whisker, just a reminder what they look like. It looks like a box, and it has whiskers at the end, and it's used for univariate data. Of course, that's why it's in data A. So we're basically looking at the entire population of our data, or the entire data. This is your lowest point. This is your highest point. This is what's called the first quartile. Okay, the first quartile. Don't have my stylus, my apologies. This is the second quartile, this line right here. This one here is the third. And this is your max. Now what is a quartile? If you took all the data and you split it up, the second quartile is exactly the middle. This is the second. Okay, so that is the middle of everything. So if you listed all your data, and if there's 20 numbers, it's right here, or 21 numbers, it's right there. It's the middle number. That's what the second quartile is. The first quartile is of all this data, the bottom half of the data, it is the middle number for this one. That's the first quartile. So basically, it's the median of the lower half. Okay? So that's important for us to recognize. And then third quartile is the median of the upper half. So in this upper half here, this part right here, it is this portion. So that's the third quartile. And then, so the big thing that we want to be able to do, because our calculator can do a lot of this for us, and so doing this by hand really doesn't help us much, but is to understand it's a measurement of percentiles. So percentile, so what percentile are you? It's a ranking. Okay, so percentiles rank you. So if you're at 30 percentile, you are better than 30% of the population, or 90, actually better than 29% of the population, 29.99. So percentile. So that would be that you're better than 30. So like in this case, if you're at the first quartile, you're better than this 25% of the population right here. This part, you're better than, or higher than, or maybe even worse than, depends upon what you're ranking here. If you're the second quartile, that means you're at the 50th percentile. If you're the third quartile, that means you're the 75th. So this is 25, this is 50, this is 75, and of course here's the 100. So if you were like somewhere on a box and whisker and you just say about yay, you're somewhere between the 50th and 75th percentile. So you might be around the, say, that might be approximately the 60th. So this is a very quick way to represent data. There's more complicated ways, which we will actually do in this unit. But to tell us a percentile where you're at, we're in the 60th percentile, that's a guess. There's a better way to do that later on. Okay, but for box and whiskers, the biggest thing here is that we have a bunch of numbers. I'm going to use my calculator to do this. I'm going to show you how to use your calculator to do this. Notice I have listed them all in order. So first off, how many numbers do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 numbers. So that means after 6, I have 6 below and 6 above. So 3, 4, 5, 6. This is the divider mark right here. So I have 6 below, and I have 6 above, so I've got this one here. This is the first quartile. I have it right here also. So that's your third quartile. See this box that we're making? Now what are these actually, and this goes all the way out to your whiskers here. Okay, now this shows it being normal, and this is not normal data, but now the second quartile, notice it falls between 15 and 18. Well, what number is that? That is 33 divided by 2. How did I get 33? 15 plus 18 divided by 2. Since it didn't fall right on a number, I had to do the average here. So 15 plus 18 over 2, which is 33 divided by 2. So 16.5 is this value. Then this one falls between 10 and 10. Well, that means it's still 10. The average of 10 and 10 is 10. The average of 19 and 21 here is 20. Okay, so moving on. So this is how we do it by hand. If we're using a calculator, you're going to hit the stat key, which is right there. Let's see if I can get a better color here. Stat. It's a very important key for us in this unit. We use the matrix button in the other unit. This one we're going to be using the stat key a lot. Notice it says edit. We're going to edit our list. And this is the screen you're going to get. So I'm going to go ahead and make sure this says list 1. If it does not say list 1, then you're going to go back to this screen, hit stat, and you're going to hit enter on setup editor, and it will bring back list 1. So if list 1 is gone, then you go back and you go to setup editor, which is this right here, hit enter, and it'll bring it back. If you have a bunch of data that's already there, use your up arrow key, go up to the top here and hit clear. Clear. If you hit delete, that's bad. Delete will actually delete list 1, and then that's where you have to go back and do your setup editor. So that's why if it's gone. So anyhow, we're going to hit clear and put them in there. So now I've listed them in there, 8, 9, 10, etc. I just type it in, hit enter each one. Now I exit out of that and I go back and I hit stat again, and now I'm going to go calculate. So now we're in univariate data. That means we want one variable data. So that's why we're in the, oops, bad color, univariate. Univariate. Okay, and that's why we want the two variable, or the one variable stats. Hit enter on that. And there's a bunch of information here. This is the average. This right here, this thing here, this sigma, that means what is the sum of all the numbers. If I add all those numbers up, it's 191. This one is the sum of all those numbers squared. So if I square each one of those numbers and then add them up, it's 3,495. Okay? These are called standard deviations. We'll get to that in a little bit. This is saying number. There's 12 numbers, as I said there was before. So that's what these all represent. So this is the average. This is adding them all up. This is averaging up all the squares. This is our standard deviation. One's normal, one's not. One's for the population, one's not. And then if you, because you see how there's an arrow here? If you push the down arrow, you're going to get this next screen, which is going to give you the 5-number summary. The minimum number is 8. The first quartile is 10. The median is 16.5. Third quartile is 20. And the max is 27. Well, what's nice is I don't think you have to put them in order. I think it'll automatically figure this out for you, so I don't think you do. You may have to sort it, I don't know. But it's going to be able to find the 5-number summary. So these are 5 numbers that we need. The min, the first, the second, third, and max. Boom. Now, I want to be able to graph this. I'm going to hit this button here. See, it's in blue. It's a stat plot. So we use the blue button. So I hit second, hit that button, and then this button here, and it's going to bring me this screen. Currently it says off, and currently it's going to plot a dot plot, or I guess scatter plot, I should say, not a dot plot. Scatter plot using list 1 and list 2. I don't want that, so I'm going to hit enter on that. I hit enter, and now it was off. I now put it on, so I use my arrow key, hit enter on the on, and then it was here on the scatter plot. I don't want the scatter plot, so I use my arrow key, moved it over, boom, boom. So this is a scatter plot, a connected plot, histogram, box and whisker, box and whisker. I think that's another connected graph. I don't know what exactly the difference between them. There's something. These two are what we want. The one here on the left has outliers. Okay, outliers. It will show us an outlier if we have it. And make sure we're using the correct list. We want list 1 because that's what we're using. Okay, we're using list 1, so that's what we put it in there for, so that's what we're going to use. Now, in order to get this screen here, I did not show this in the video, or I did not show this in when I did. So there's zoom and it's number 9. If you scroll down to number 9, it says zoom stat. So it will make a perfect window for this. And so here's our box and whisker. So the box and whisker tells us quite a bit. It tells us how the population's, how condensed it is. You know, especially if you're comparing one box and whisker compared to another. But notice there's some things that we can recognize out of this box and whisker. Okay, so notice where the grouping of the data. There's 25% of the population's here, 25% is here, 25% is here, and 25% is here. And there's no outliers because there's no single dots at the end. So 25% of the population is there. So the lower 25%, it's really close together. Then there's the other 25% of the population, which is it's more spread out. And then the third 25% is condensed again back together. And then the final 25% is really, really spread out. Just random made up numbers, so really not a whole lot that I can gain from this because it's all random, sort of just made up stuff here. But it's still, if I had a number that fell right here, then I would know that it's and this is 25% mark, and this is the 50% mark, so it's about 35%. It's just a guess, and it's just a good approximate method to display data. And so again, MEP scores will show that stuff. Well, I did say that I was going to talk about outliers. Well, there's more than one type of way to represent outliers. There's the 1.5 rule. So the 1.5 rule means you're going to take 1.5, you actually are going to use 1.5 as your multiplier, and you're going to take it and multiply by the third quartile minus the first quartile. Okay, so we're going to take the 1.5 multiply by the upper quartile. So let's see what those numbers were. If we write these down, the number that we have here is 20. So 20 is the upper or the third quartile, and 10. Let's erase that. I think that's right. And 10 is the lowest one. So now 1.5. So 1.5 times 20 minus 10. Okay, so this is the interquartile range. Whoops, minus 10, not plus. Okay, minus 10. So 20 minus 10 is 10. So 1.5 times 10. It's 15. So now I'm going to go and take 15. I'm going to add it to this number here. 15 plus 20 is 35. There's no number greater than 35. The highest one's 27. So there's no outliers in the upper end. And then if I subtract 15 from 10, then that's negative 5. There's no numbers that are less than negative 5. So therefore, there are no suspected outliers in this problem. And so that's the 1.5 outlier rule. And it's a quick and easy one. It's definitely much easier than the other one, but it usually works. It's going to tell us if something should be considered an outlier based upon the data. Because just because it's 15 away here, other data, you know, the numbers get larger. So when the numbers are larger, 1.5 times that, it means that you can really go out a lot further and not be considered an outlier. Alright, I hope this video has been helpful. Hopefully you guys pay attention. You can rewind, look at all this, and check out how to do this on your calculator. And good luck on that problem.